Today we're going to discuss real numbers, which is found in section 5.6 of your BJU Press Pre-algebra textbook. So let's begin with reviewing what a set is. So a set is just a collection of objects. So if we have a collection of something, then we have what's called a set. Now an element or a member is something that is in a set. So everything that is in a set we can either call as an element of a set or a member of a set. So for example, here is a set, and we're going to call this set A. So sets are usually denoted with capital letters, such as set A. And then we usually use these little braces to put our members of our set in. So members of this set include 3, 6, 12, and 24. And then we could say 6 is an element of set A. So you see this little, it almost looks like a C with a line going through it, or almost like a weird shaped E. This symbol here means it's an element of. So 6 is an element of A. And then we can also say 8 is not an element of A because 8 doesn't belong in the set A. 8 is not a member of set A. So there are things called finite sets, and so finite has a specific number of elements. So there's going to be either 20 numbers in the set, or 20, items in the set, or 20 elements, or there's going to be 15, or there's going to be 5, or there's going to be 3. But no matter what, there's going to be a very specific amount of numbers in that set, or a specific number of elements in that set. Is what we call an infinite set, just like infinite kind of sounds like infinity, never ending. So in an infinite set, we cannot count the number of elements in that set. So for example, here I have set B, which is the set of 2, 4, 6, 8, ... This ... that's an ellipse. And that represents that we continue in the same pattern, right? So it looks like we're counting the even numbers. So 2, 4, 6, 8. So set B would be the set of even numbers. And since there's an infinite number of even numbers, we would call this an infinite set. We also have something called the empty set. The empty set has no elements inside of it. It uses these symbols. It's like a 0 with a line through it, or you can also use braces that have nothing inside them. You're never going to use them together like this though, because then you would have the set of an empty set, which doesn't really make sense. So never use them together. You're either going to use the 0 with a slash, or you're going to use the braces with nothing inside them, but don't use them together. So we have something called disjoint sets. So disjoint is kind of like where things don't coincide, right? So they have nothing in common. So disjoint sets have nothing in common. So for example, set C has 6 and 12 in it, and set D has 13 and 5 in it. So those two sets have nothing in common, so we would say they are disjoint sets. We also have something called a subset. So sub kind of is like underneath or inside. So subset just means that all members of this set also belong to another set. So for example, we could say that set C is a subset, that's the symbol here, is a subset of set A because set C, everything that's in set C, the 6 and the 12, is also in set A, which can include 3, 6, 12, and 24. So there's this statement here that the empty set is a subset of every set, and then also every set is a subset of itself. So set A is a subset of set A. So let's talk about set operations. Our first operation is what's called a union. And a union is when you combine the two sets. So it's basically everything, you combine them. We want everything from every set, right? That's the union. And it has the symbol, it's like a big U. U for union, right? So if we had set D, which includes 1, 2, 3, 4, and 5, and set E, which is 2, 4, 6, 8, and 10, The union would be all the numbers in set D and in set E. So we would have 1, 2, 3, 4, 5, 6, 8, and 10. So notice how I shaded both circles for the union. The intersection is where we only look at what they're sharing, or what numbers are in both sets, right? And so that has this symbol. It almost looks like an N for intersection. So again, we're going to look at set D and set E. If we're looking for the intersection, it's the numbers that are both in set D and in set E, which would be the numbers 2 and 4. See how I shade here the numbers 2 and 4. Okay, so for the set of real numbers, we have sets and subsets. So we have the real numbers as one big set, right? Real numbers is one big set. And inside the set of real numbers, we have irrational numbers, right? So irrational numbers are numbers like the square root of 7. Like it's not a perfect square, it's a decimal, and the decimal is non-repeating, right? That's what irrational numbers are. And then we have what are called rational numbers, which are the symbol Q. So rational numbers are decimals and fractions, okay? And these decimals need to either be repeating or can be rewritten as a fraction. And then inside the set of rational numbers, you have the set of integers. So the set of integers are positive and negative whole numbers. So -5, +5, -20, +20, and it includes 0. So the set of integers is a subset of the rational numbers, which are a subset of the real numbers, okay? The next subset that we have is the set of whole numbers. So the whole numbers is going to be 0 and then all of your counting numbers. So 0, 1, 2, 3, 4, 5, 6, 7, on and on and on. So the whole numbers are a subset of the integers because they make up part of the integers. And then that means that they're a subset of the rationals, which are a subset of real numbers. And then our innermost subset is the natural numbers, which is kind of like your regular counting numbers, what you naturally learned as a child. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on and on. So not including 0. But if you add, and that's why the natural numbers are a subset of the whole numbers, because whole numbers includes all the natural numbers plus 0. So let's do some practice plugging in some numbers. So 15 would be a natural number, right? That's the innermost number it could be in. -5/9 is a rational number because it's not an integer, because it's a fraction. -41, though, is an integer. The square root of 5 is not a perfect square, so that would be an irrational number. And then we have 0.72 repeating. That's going to be a rational, because remember, if it's repeating, it's rational. If it's non-repeating and it goes on forever, then it's irrational. Then we have 0, which is a whole number. 0 is not a natural number, so the innermost it can go is a whole number. And then the square root of 16 is a perfect square. It's actually the number 4, which is a natural number. And then last one, pi. Pi is an irrational number because it has a decimal that goes on forever but doesn't repeat. Let's review some properties. We'll start with commutative. Commutative is when you change the order. So there's commutative property of addition, and there's also the commutative property of multiplication. And it's just changing the order of your terms. Then there's associative. Associative is changing who you are associating with, or who's in your parentheses, who's in your group. So when you change your group, that's the associative property. And you can have the associative property of addition and the associative property of multiplication. Then we have what's called the identity property. The identity property is when you do something, you do an operation, and you end up with the same thing. So for addition, it's when you add 0, and when you multiply, it's when you're multiplying by 1. If you're adding 0 or you're multiplying by 1, it is called the identity property. Then we have the 0 property. For the 0 property, it's when you multiply by 0 and you get 0. Then we have the inverse property. The inverse property is when you add the inverse, or you add the opposite. And then if you have an inverse property of multiplication is when you multiply by the reciprocal and you get 1. So a reciprocal, remember, in order to be reciprocal, a number and its reciprocal has to multiply together to get 1. That's how we know it's a reciprocal. It's almost like taking the flip of the number. All right, let's look at an example. Let's name this property. Okay, so we have 15.3 times 8 minus 8 equals 0. So this would be the inverse property of addition and the 0 property of multiplication. So it's the inverse property of addition because we're subtracting the 8 to get the 0, right? And then since we're multiplying by 0, it's the 0 property of multiplication. Let's try this property. So for this one, we're changing our groupings, so that's the associative property. Okay, and so for this one, we're adding the opposite, so it's the inverse property. So for this one, we're multiplying by the reciprocal, so it's the inverse property.